I want to get this section finished, which is the last section, the last half of section 6.1. And your test, that is your online test, will be up to and including this stuff, as you know. But we're going to get this finished today, fingers crossed. And we can get started on the next section, which won't be in your test. So 3 main topics, 2 of which we've really covered, and the third one's a new one. So how do you convert degrees to radians? We're going to use this formula. If you get questions where you have to convert radians to degrees, we're going to use this formula, and then we'll talk about coterminal afterwards. So I've really just done one of each, just you know, for completeness sake. So suppose you were asked to turn 280 degrees into radians. So 280 degrees would become the following. Let's see. In radians, it would be 280 over 180 pi. And in this case, I'm going to do it as an exact value first. So 280 on the top divided by 180 on the bottom. And then you can hit the math button, choice 1, and I get 14/9 pi. And if the question just said, convert degrees to radians, that would be the answer, because that's an exact value. If it went and said to, I know, 3 decimal places, then you would still use that answer, right? That's that one there. But you would turn it into a decimal. So there's 14 pi and divided by 9, and that would be 4.887 to 3 decimal places. Now let's do the next conversion. Suppose you wanted to convert 4/5 radians into degrees, then it will be the radians, 4/5, divided by pi times 180. And if you want to get the exact answer, you just cancel out the pi's and then just find what 4/5 times 180 is. So 4/5 times 180. And the answer I get in this case is 144 degrees. And that's it. So are we all comfortable converting radians to degrees and degrees to radians? And it doesn't really matter how ugly the degree is or how ugly the radian is, because isn't it just a plug and chug formula, right? Calculator can do most of the heavy lifting. So let's talk now about these things called coterminal angles. Right, a coterminal angle is an angle that is essentially in the same place as the original. All that's different about it is that it's 360 more, or 2 lots of 360, 720, and so on. So a lot of the questions are something like, here is an angle, give me some other angles that are coterminal to it. And some are in degrees and some are in radians, and that's the first kind of question. And then the second kind of question they give you is, here are 2 angles. Are they coterminal to each other or are they not? And that's pretty much all you need to do. So let's take this one. I want a coterminal angle. I want 2 positive ones and 2 negatives. So if I take 35 degrees and add a complete revolution, right, 1 circle's worth, I will get the answer 395 degrees. That guy is coterminal to that guy. Now, if I wanted to get another one that's positive, couldn't I just take 35 degrees and add 2 lots of 360 to it? And since I don't want to do that in my head, 35 plus 720, I would get 755 degrees. Now, if you want to find 2 angles that are coterminal to this one, but are negative, you would start with 35 degrees and you take away 360. And you start with 35 and you take away 2 lots of 360. And keep doing it until you got as many answers as you need. So if you take 35 degrees and subtract 360 from it, you will get negative 325 degrees. So that's coterminal to 35. And if you do the next one, it's 35, take away 720. And the answer to that is negative 658 degrees. And we are now looking at the answer to that question. Find two positive and two negative angles that are coterminal to 35. These are the two pluses and these are the two negatives. Would you agree that's pretty easy to do, right? I could just insert any angle I like, and couldn't you just add 360 and then add, 720, or take away 360, or take away two lots of 360, and you'll get the answers you want. So I'm not going to do this one now unless you really want me to. Couldn't I do the same question again, but with coterminal to 100? Right. Wouldn't that be what, 460 and 820? And if you took it away, you get negative 260 and negative 620. Now, if that's how you find coterminals for angles that are degrees, then what would you be doing if it was 4 pi, right? Which is obviously radians. Well, if you add a complete circle worth, well, isn't a complete circle 2 pi radians, right? So if you imagine what that might look like, can you imagine this angle here is pi upon 4? Then a coterminal angle would be this one. You go all the way around the circle and then do that again, which is what this is. And if you do this on your calculator, you'll find it's 9/4 pi. And if you want another angle that's positive, well, instead of adding 2 pi, don't you just add 2 lots of 2 pi, which basically gets you another 8 of those, and you would get that. Now, this is going to be really messy, but if you wanted to know what that angle looked like, you'd go round once, you'd go round twice, and then you do that guy. So it's basically just going round 360, round another 360, but now it's go round 2 pi and then go round another 2 pi. Now, that's gave me two coterminals that are positive, and then you could have two coterminal angles that are negative. Well, if you take 2 pi away from that, you can check it, you get 7/4. Let me show you how I could do that in the calculator. Forget about the pi's, they just disguise the question. There's a quarter, take away 2, and then math button number 1, there's your negative 7/4. Cool with that? Calculator can do it if it's weird. If you want to get another one that's negative, you just do that one more time. And what would that get me? Negative 15. And now we have 4 coterminal angles, 2 which are positive and 2 that are negative. Are you comfortable with that question? Right. Now, very often in WebAssign, when you've got more than one answer, it will ask you to write them down as a comma separated list. And you've probably seen this before, but let me just remind you. So you type in the guy, comma, you type in the second answer, comma, then the third answer, comma, and then the last answer. So that's what they mean when they say write your answers in a comma separated list, right? Just a whole load of commas.
Is it biggest to smallest, or is there an order that it needs to have?
I'm looking. It doesn't say, but now you've said it, I think smallest to biggest kind of makes sense, doesn't it? So I hope WebAssign is clever enough to take it in no matter what order you shuffle them up. I hope it's clever enough. But if I wanted a rule, I would say smallest to biggest makes most sense. And it's definitely going to be easier when the angles are degrees, minus 190, minus 70, 20, 40, that kind of thing. In that situation, I think it lends itself really well to doing it that way. Okay, let me just show you what that looks like as a homework question, so you're comfortable with the way they phrase them. So the measure of an angle in its standard position is given. Find two positive angles and two negative angles that are coterminal to the given angle, and then enter your answer as a comma-separated list. Now that you know what all the phrases are, can you see that you're basically going to take 310, add 360, and then add 720, and then 310, take away 360, and then take away two lots of 360, and that would be your answer. And as Lena suggested, probably smallest to biggest, just to make it easy to check. No, nobody needs to. Go away. Go away. I'm not used to Windows 11 yet, so Windows pop up when you, if you're not careful, try that again, this time deliberately. Do you see that? Don't know if you've got Windows 11. You don't need to click anything. You just need to move your mouse pointer next to something, which I guess, so you have to click the start, but you don't have to do that. That must be for lazy people who don't want to click a mouse button. I can't think of any other reason Windows 11 introduced that new thing. So can you see the same kind of questions in written down in radians? Okay. So let's just do a little awkwardness to that question. Suppose I gave you negative 30 degrees. And I wanted two more positives and two more negatives. How could I do that? I don't need to know the numbers, but I want two coterminal angles. Two are positive and two are negative. How would I go about getting those four answers?
Add and subtract lots of 360.
Yeah. Simple as that. So what happens if I had that guy? Now, if I add a 360, you get that guy. So won't he count as one of the coterminal angles that's negative, even although I got it by adding 360, right? So you may have to figure out add 360, take away 360, take away 360. But you've got to remember that the final result is I want two negatives and two positives, right? So if I add 360 to that one, won't that count as my first positive answer? And then if I add another 360 to that, that will be my second positive answer. How will I get my other negative answer in this question?
Subtract 360.
Right, so now not from that one, because that just gets me back to the guy I started with, right? But subtract it from that, right? And off you go. Are you comfortable with that? They might give you an awkward one, but just like you say, don't you just keep adding 360s till you get two positive guys and taking away 360s till you get two negative ones that you haven't got yet? And when it's radians, don't you just 2 pi, add 2 pi, take away 2 pi, take away 2 pi? I'm getting a good vibe of that. Would you say you're comfortable now that if I gave you an angle, you could get me two positive and two negative coterminals? Right. So let's now give you a different question. And this one, for instance, is a version of question 28. Here are two angles. And you have a choice. They are coterminal angles, or they are not coterminal. Can someone tell me how you could find out, what you could do to decide? And guessing doesn't count.
You can
Just
add
add-
360 to the lower number or subtract 360 from the higher number.
I never thought of that, but I like that. Yeah. Add 360 to that or take away 360 from that. That works. And if the numbers are too far apart, I guess what? Add 720 or take away 720, right? And I like that method. None wrong with it. Do it. It works. Can anybody tell me a different way to approach that same question?
If you subtract the numbers from each other and they're either 360 or 720, like going back, counting by 360, then it'll be a coterminal.
Yeah. So in this case, there's 360, right? That's just because that's the way my brain works. Did you see there were two totally different ways of coming up with the answer, right? Take the little guy and add 360 or add 720 and see if it fits, right? Or subtract them. Obviously, big take away small makes more sense, right? And if the answer is 360 or 720 or something to do with 360, wouldn't that count as a coterminal angle? So for instance, if I went and said, well, how about 40 and 400? Well, if you subtract them, if you do it that way, you get the answer 360. So that's a yes, isn't it? Or if you do the add 360 to that, it works. So you get yes again. I think both those are quite valid, aren't they? How about this one then? Wouldn't we have to invent a similar kind of rule that we did with the degrees? Radians are just awkward, aren't they? Because they tend to be weird fractions, whereas, 310 is easy, right? It's a nice number. You can add 360. So do you want me to, well, not want to, I'm going to do it with a subtraction, and then you can tell me if you want me to do it the other way. So if you take the big guy and you subtract the little guy, we'll just see what the answer is before we make a decision here. So I like 23/6 take away 11/6 is that guy. Oh. Isn't that a yes? If the difference is 2 pi, suppose the difference was 4 pi or 6 pi, because that could happen, right? Wouldn't they also be yeses?
Yes.
Okay. If the answer was 3 pi or 7/6 pi, wouldn't the answers then be no? So it's a pretty simple test, right? Biggest one, take away smallest one. If your answer is some version of 2 pi, like 2 pi, 4 pi, 6 pi, or some version of 360, right? 360 or 720 and so on. If it's not, then it's not coterminal. Now, if you wanted to do that the other way, wouldn't you just take 11/6 pi and add 2 pi to it and should hopefully get that. So let's see what that looks like. 11/6 add 2 and then go math number 1 and yep, you see it matches 23/6. Do you want to see more of these? Here's 2 angles. Are you coterminal, yes or no? Or can we move on? You want to see some more of these? Like a thumbs up? Are we good? Okay. So here is another version of the coterminal angle. And this one is a version 34. And you're given 800 degrees and you're being asked to find a coterminal angle, which is essentially an angle that looks just like that guy, in the range 0 to 360 degrees. So there's your puzzle. I've got 800 degrees, but I want to find another angle, a coterminal angle, that is in the range 0 to 360. Don't need to tell me the answer. You can if you want, but you don't need to. But can you tell me how you would find the answer? What would I
Subtract
do?
720.
Okay, so you would subtract, I'm just going to rephrase what you said. You would subtract multiples of 360, right? And you're quite right in this case that the right number would be 2 lots of them. And that comes out to be a rather interesting answer, 80 degrees. You could, this is the same question, but you could simply do it like this. And it's kind of more of a calculator point. Right, I got 800. I'll take away 360. Nah, that's too big. I'll take away 360. There we go. Can you just keep taking away 360s till you got a number that works? That might be worthwhile if you get a number like, you know, some ridiculous number like 1305. Because couldn't you maybe misjudge how many 360s? You might think it's 3 and it needs to be 4, you know, that kind of thing. So if you want to just take the easy road out, there's the answer. Take away 360, too big. Take away 360, too big. Take away 360. There we go. 225. And how do I know that that's the stopping one? How do I know that 225 is it and I don't do any more?
Because it's less than 360 and greater than 0.
Yeah, it's in the range I want. Now, using that same tactic or strategy, shouldn't you also be able to take 15/3 pi and find a coterminal angle in the range 0 to 2 pi, right? In other words, find the angle in the unit circle that's the same place as that guy is. Well, oh, that's a bit messy, but I should be able to do it. There's 15/3, right? I'm going to change that to 16/3 because that was a nice number and I don't want it to be a nice number. 16/3, right? Take away 2, right? And let's see what that looks like as a fraction. And that is 10/3. Is 10/3 pi in the range 0 to 2 pi? Nope, it's not, right? It's 3.3 pi. Okay, so I'll just take away 2 more. And the answer I got is that number, which if I turn it into a fraction, is 4/3. So if you were going to do it as, you know, based on using your calculator, you could certainly do that. And this would be your answer. And I could probably do that in my head. Isn't it easier just to take away 2 pi, which is 6/3, and then take away another 6/3 until you get this answer? So far, so good. Right, let's put in a negative one. And this is similar to question 35. I want a coterminal angle in the range 0 to 360. What would I do? You can tell me the answer as well, but what would I do to get the answer?
You would add 720.
Would you need as much as 720?
Add 360.
Try 360 first and then see what you got. Would you agree? You don't need as much. So if I was just being, you know, I got my calculator here, I just want to make my life easy. There's the start angle. I just add 360 Oh yeah, that's in the range 0 to 360. Stop. Cosihydrodians. Wouldn't you just add 2 pi? So let's see what that looks like. Negative 7/5 add 2 gets me 3/5 pi. And 3/5 pi is in the range 0 to 2 pi. So I stop. If it was a really big negative, like that, I might add 2 pi, see what we get. Well, that's not as big as I thought, but that's fine. It'll still work. And the answer I get is negative 7/4 pi. Okay, well, just add another 2 then. And I get 1/4 pi. So eventually, won't I get an answer that's in the range that I need, which in this case is 0 to 2 pi. Are we good with those questions as well? Do you want to see some more, or you feel if I give you an angle that's not in the range 0 to 360, you can find a coterminal angle that is inside the unit circle in radian or in degree format. And it's really all about adding or subtracting 360s or adding and subtracting 2 pi's. I think I got one nod. I think we're good. I hope we are, but it's really what you think, not what I think. Are we good? Right, let's move on then. We are finished. Everything you need to know for your test and for your homework. So we're now going to move on to our next section, which is section 6.2. We are going to look at right-angled triangles. And I don't know how much of what we're about to do you've met before. For some of you, it'll be, everything's new. Right? You can't remember doing it or you've never done it. And for others, yeah, I did some of this in, back in high school last year or whatever it might be. So just bear with me if you have seen this before. A right-angled triangle, it's a very special triangle. It's one that has a corner angle of 90 degrees. And there is a pretty standard looking right-angled triangle. Now, in a right-angled triangle, I am going to choose one angle here to be the angle of interest. So the angle of interest here is theta. When you have a right-angled triangle and there is a specific angle of interest in it, we can name the 3 sides. So each one of these 3 sides has a very specific name, and it gets its name from this guy's perspective. Does anybody know what the name of any one of these 3 sides is? Have you seen that before?
Obtuse, adjacent, and hypotenuse.
Right. This fella here is called opposite. Oops. This guy here is called adjacent. And this sloping one is given the name hypotenuse. This is totally new from you. From this angle's perspective, the side that's opposite it, furthest away, is called the opposite. The one that's right next to the angle is adjacent to it, is called the adjacent. The long sloping one is called the hypotenuse. And that's how we would name the 3 sides of a right angle triangle. So I am going to orientate some different right angle triangles. And the corner angles are here. And I'm going to call this the angle theta. Then I'm going to make it this one. And lastly, I'm going to make it that one. And we're going to do some abbreviations. Instead of opposite, from now on, it's going to be called OPP for short. And instead of adjacent, I'm going to call it ADJ for short. And instead of hypotenuse, it's going to be called hype. Right, so from now on, if you ever see me writing that, I'm just saying opposite, just abbreviating it. Now we're going to make things a little bit weird or awkward or whatever. I'm going to call this triangle 1. I'm going to call this guy triangle 2. I'm going to call this third one triangle 3. So we are getting practice at how to name the sides of a right angle triangle. So we're focusing on right angle triangle number 1. The angle of interest is down here. What one is 13? Opposite, adjacent, or hypotenuse? What is 13?
Hypotenuse.
Agreed. Hypotenuse is the long sloping one. You can also notice that it's opposite the right angle, isn't it? Okay. Which one of those two is the adjacent?
12.
Okay. There's the angle of interest. Adjacent. So obviously that's the other one. Okay. We're on to triangle 2 now. What is 8?
Opposite.
What's 10?
Hypotenuse.
So 6 is the other one. Okay, last one. Which of those, how long is the adjacent?
Three.
Opposite. 4. Hypotenuse. 5. Are you comfortable that if you get a right angle triangle upside down, back to front, or any weird orientation, doesn't the naming of them not change? I mean, if they really bug you, can't you take every single one of them and just turn it so it looks like the first one? I mean, if orientation really confuses you, you could do that. So right now, what we know is that you have a thing called a right angle triangle, and that there are 3 sides called opposite, adjacent, and hypotenuse, and that they get their names because one of the angles, one of the corner angles, is going to be the angle of interest. So far, so good? So how does right angle triangles interact with trig? And in particular, the trig ratios, sine, cosine, tangent, and then the other 3, cosecant, secant, and cotangent. Well, this is how they interact. So here's a kind of standard right angle triangle again. Here's my angle theta, the angle of interest. This side is the opposite. This side is the adjacent. And this side is the hypotenuse, all good. The 6 trig ratios, let's do the first 3, because they're the most common, the ones that you use most often. You can calculate what the sine of that angle, whatever that angle happens to be, by using a ratio of 2 out of the 3. The sine, cosine, and the tangent. You can get them by doing one side divided by the other. There is a mnemonic, which you hopefully have heard of, which is a funny word. Mnemonics just a word or the letters of that word that are there to help you remember a formula. Please, at least some of you, have you heard of SOHCAHTOA before? Right. So if you've never heard of it before, it's like Krakatoa. Remember the volcano that exploded? Those movies about it, right? Krakatoa. It sounds like that. It's called SOHCAHTOA, and it's basically 3 bits: a saw, a ka, and a toa. And what that does is it allows us to find what these are equal to. The sine, for instance, OH, means opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. Do some of you remember that guy? Because you may have met it somewhere. And others, never seen it in my life before, right? But now you know it. So far, so good. And now, I should have prepared better, but I've figured a way around it. We have the other 3 trig ratios. What's the upside down of sine called? It's called the reciprocal of sine. What was the name of that ratio?
Cosine?
No. But it sounds like cosine. It's not.
Secant.
Yeah.
No.
Cosecant. Right. So, oops. Cosecant. Right. What's the reciprocal of cosine then?
Oh, that's secant. Sorry.
That's secant. But I can understand that, because doesn't cosecant sound like it's got the word cosine in it? I know it's, well, to me it sounds like it's got it, but actually cosecant then is the reciprocal of him. This isn't working quite as well as I thought it was going to do. I'll do them over here now. You don't need to write this, guys. I'm just repeating myself. So say you don't need to write this. I'm just repeating it. So cosecant is the reciprocal of that. So basically, you just turn this guy upside down. Cosine, right, upside down gets you a secant. So you turn this guy upside down. And tangent, well, when you turn him upside down and get his reciprocal, it's called a cotangent, and you get that guy. So there is a very, very close relationship between the lengths of the sides of a right angled triangle and the trig ratios, sine, cosines, and so on, right? For instance, the sine is this side divided by that. And the adjacent would be, the cosine would be the adjacent divided by that. And the tangent would be that one divided by that one. Isn't that kind of nice that they have such a nice connection to each other? And what we're going to do is we're going to use that connection to help us solve problems involving right angled triangles. So here's my first little problem. Suppose I have a right angled triangle and the sides are 6, 8, and 10. And I would like to know the sine, the cosine, and the tangent of that angle theta, that one there. And while I'm at it, I want to know the cosecant, the secant, and I also finally want to get the cotangent. I can find all 6 trig ratios from this right angle triangle. So if I wanted to get, for instance, the sine, I better put my little nibbles in. This guy is opposite, this guy is adjacent, and this guy is hypotenuse. If I wanted to get the sine, it would be 6/10. If I wanted to get the cosine, it would be adjacent over hypotenuse, 8/10. And if I wanted to get the tangent, it would be opposite 6 over adjacent 10, which is those guys. But of course, if a fraction can be simplified, nobody knows that one should be 8. There we go. You'd get that. Does that seem reasonable? Right, now if I wanted to get the cosecant, the secant, and the cotangent, couldn't I just use these answers and turn them upside down? Isn't that a lot easier to do than, you know, do the formula from scratch? Are we cool? So if I give you a triangle that looks like this, do you feel comfortable you could get the 6 trig ratios? Suppose I gave you a triangle like this. And I only want, for no particular reason, I only want to know what these 2 are, right? Not the whole 6, but I only want those 2 because I only want those 2. This is how you would approach it. From this angle's perspective, I need to name the 3 sides, okay? What name will I give to the 13?
Hypotenuse.
Okay. What will I call the one that's 12?
Adjacent.
And then I've got this side over here. And unlike this question where you were nice enough to tell me all 3 sides, you see in this question, they only tell me 2. That's not a problem. Can't I find the 3rd missing side? What's the name of that funny Greek guy that we use to get it?
Pythagorean. Something
Right.
like that.
Yeah, Pythagorean theorem. Are you most, do you write it that way? Do you write it that way? It doesn't really matter to me. How do you remember writing it? I'll try and be consistent. This
It
top
was
one,
first one.
second one, or the
I
top
thought
one?
it was the first one.
Is that the way
Yes.
you're used to being written?
Yeah.
They're both the same, by the way, right? They do exactly the same job. Just so I don't, you know, confuse you by going different roads. So the 2 small sides are always equal to the hypotenuse squared, right? So in this world, the hypotenuse is 13, right? And what I've got is the guy that I don't know, which I guess I could call him opposite then, the opposite squared, right? Plus 12 squared. So the side I don't know, the opposite squared, plus 144 gets me 169. The opposite squared then, well, if you take 144 away from both sides, you get that. And then to find the opposite, don't you take the square root? And although normally when you take a square root, there's a plus minus thing going on, when it's physical distances, don't you just pick the big one, meaning the positive one? In this case, we now know that guy's 5. So name the sides according to the angle of interest. If there's a missing side, use Pythagoras to find out who it is. And then you can do the sine. And the sine is the opposite over the hypotenuse. And in this case, 5/13. And the cosine will be the adjacent over the hypotenuse. which in this case would be 12 over 13. So far, so good. No questions? We good? Okay. I like good. Oh God. Also, I don't notice the time. So last name down for attendance.